All right, so welcome back. We're going to learn how to solve system of equations by another method called substitution method. And in this particular case, we have the second fraction containing a fraction, but we also have the y coefficient being 1. And when we see that, I'm going to start with that equation because I can easily solve for one of the variables and then substitute it back into the other equation. In other words, I can isolate y for the second equation much more easily than the first equation, okay? So that is one of the reasons why I'm starting with the second one. So let's go ahead and solve for y for the second one, okay? And all we got to do is subtract 7/3 x. And we do that on both sides. And again, we want these to cancel. So then you're just left with y equals minus 7/3 x. Actually, it doesn't really matter what the order is, so I'm just going to leave it as minus 5 minus 7/3 x. We don't have to get it in slope-intercept form. Just go ahead and isolate the y variable. Okay, and now this part right here, okay, we look at this part right here. Now we take that and substitute it into the first equation and solve for x, okay? So here we go. We're going to do that over here. So here we go. We got the first equation plus 3. And now we're replacing, remember we're replacing the minus 5 over 7/3 x with the y. You see that? Okay? And that's going to equal 4. So remember that I'm replacing this with y. Okay? And now I just distribute the 3 to get rid of the parentheses, and then we should be on our way of solving the equation, okay? So here's what we have. We have 7x plus, actually, a negative and a positive is a negative. 3 times 5 is 15. Okay? And then with this, okay, the 3's will cancel. When I take 3 and multiply it by a negative 7/3 x, the 3's will cancel. Then I'm just left with negative 7x. Okay, and then now go ahead and do that. Bring down the 4. Okay, and then get all the x's on one side and then numericals on the other. Okay? All right, so now look what happens here. 7x minus 7x on the left side cancels. And then now I'm just left with minus 15 equals a 4. That is definitely a false statement. Okay? So the answer is going to be no solutions, or no solution. Okay? Those two quantities is false. Negative 15 does not equal 4. And that's all. There's no solution to that one. Okay? So let's try another example. Okay, so here we are going to choose one of the equations, all right, or choose one of the variables to eliminate that you think would be easier to do, all right? And I see something right away. I see the second equation is almost solved for y, but not quite. There's a coefficient of 8 next to it. So if we go ahead and divide that second equation by 8, okay, watch what happens. You get y equals 72 divided by 8 is 9. Okay. This should be an x, by the way. 72x. Okay? So that's going to be a 9x plus 1. All right? And now we already have one of the variables solved, and then we're going to take this and just go ahead and substitute it into the y variable for the first equation. You remember you're solving it into you're substituting into the other one. Okay? And then we'll do that over here. Let's see what we get. Okay, so here we go. We're going to take the y and we're going to replace everything with 9x plus 1. Okay? And that's going to equal 1. All right? All right, so let's go ahead and simplify that. This is going to be when I distribute the signs, they're going to stay the same. So this is just going to be 9x and then plus 1 equals 1. Now you notice that the 9's cancel out. Okay? And then you're just going to be left with a statement of 1 equals 1. That's true. Okay? So you're going to have infinitely many solutions, okay? As long as those two quantities equal each other, then you'll have infinitely many solutions. All right? So that would be the answer, this right here. Not 1 equals 1. You have to specifically say infinitely many solutions. All right? Let's do another example. All right, so if you look at the third example, again, x is going to be easy to eliminate rather than the y. So I'm just going to stick with that and multiply everything by a positive 5 because the other equation is negative x, right? It has a negative x in it, so we don't have to worry about the signs, okay? So when you do that, all right, the first equation stays the same. And then the second equation is going to be 5x plus 35y equals 50. And then now I can cancel my x term and then go ahead and add the other one. So what do we say that was? 38y, and then this is what it's going to be, 38. Okay? And then if you divide everything by 38, then you're going to be left with y equals 1. And then we're going to choose one of the original equations and plug that in. And then, of course, I'm going to choose my second equation because it's a little bit easier. And then I'm just going to put in my 1, x plus 7 times 1 equals 10. Okay, and I can solve for x now because this is going to give me 7, right? 7 times 1 is 7, and then I just subtract 7 on both sides, and then now I just have x equals 3. Okay, don't get your 7's cancel. All right, so my solution is going to be 3, 1. because you want the x to represent 3 and the y to represent 1. You want to write it in a coordinate form. And that's the point of intersection. Okay? This right here is the point where the two lines will intersect. And that's really important to realize. Okay? So where you find that point, and that's the point of intersection, you plug x for 3 and y and 1 into that system. They're gonna equal on both sides, and then it'll confirm that it is in fact the intersection. Okay, so just to kind of keep that in mind. Okay, let's do one more example. Okay, so we'll have 7x plus y equals 1, and then we're going to have y equals minus 7x plus 1. All right. Let me rewrite that so we can read that. Okay, minus 7x plus 1. That's a little bit better. All right, so now, again, we want to choose one of the variables to solve. You notice that y is already solved. It's telling you it's equaling minus 7 plus 1. So what you should do is you take this, and then you should immediately plug it into the other equation for y. So you're just going to have 7x, right? And then we're going to plug in basically minus 7x plus 1, okay? And that's going to equal 1. So all we're going to do is distribute this positive sign, okay? And then you're just left with 7x minus 7 plus 1 equals 1. Okay? All right. Oops, I copied the wrong problem down. So I need to go ahead and rewrite that last problem. Totally wrote it incorrectly. This is the problem that I meant to write. Because we did that one already and I wrote it twice, so I apologize. Okay, so now this is the one I want you to solve. Okay, here we go. Now we're going to use substitution method. Now we're going to choose a variable that we're going to eliminate, and I can clearly see that the y is going to be the easiest to work with. Okay. Actually, the second equation we're going to solve for y, because all we're going to do is move that x over, that 7x over. And if we do that, then these will cancel, and then you're just left with y equals 1 minus 7x. And you're already there. You already have y solved. Okay? So now we're going to take this, all right, and plug it into the second equation, which will be that. Okay? So here we go. All right? So we have minus 5x plus 3. And then we're going to substitute that with 1 minus 7x. That's going to equal 55. Okay? And all we got to do now is just distribute the 3 over the parentheses so we can eliminate them. And then, of course, 3 times 1 is 3. 3 times minus 7x is minus 21x. All right? And that's going to equal 55. Okay? Now, if we go ahead and combine the x terms, negative 5 and negative 21, that's going to give me negative 26x. Okay, so we want to be able to combine these two terms on the same side, and that's going to give me minus 26x plus 3 equals 55. Okay, and then of course, we're going to remove the 3 by subtracting that, and that way this will cancel. And then you're just left with minus 26x equals 55 minus 3 is going to be 52. All right. And if you divide both sides by a negative 26, okay, x is going to, in fact, equal a minus 2. All right? Because a positive divided by a negative is a negative. And 56 divided by 26, that goes into it 2 times. All right? But we're not done yet. We need to solve for y. So why don't we just pick one of the original equations? I'm going to pick the second one, which was 7x plus y equals 1. And now I'm just going to replace the x with negative 2, because that's what we got. And then now 7 times negative 2 is negative 14 plus y equals 1. And then if I add 14 to both sides, that cancels, and then you're going to get y equals 14 and 1 is 15. So that is my solution. Okay, so my solution is going to equal negative 2 comma 15. Okay, because this is my x and that's my y. All right, so there you have it right there. Okay, so that concludes my video of solving system of equations by substitution. I hope that you found this to be helpful, and thank you so much.